Good afternoon and welcome to our next science lesson where we'll be looking at forces once again. Today our learning intention is to identify the effects of friction between moving surfaces. So we've got an option of 3 experiments today. First question is, what is friction? So if you pause the video just for a couple of minutes and write down what you think friction is and if you can think of any examples. So just pause the video, write down your ideas. Okay, so hopefully you've written your ideas down. Friction is the resistance that one surface or object encounters when moving over another. So that's the official definition of friction. And to help you understand that, I've put in a link which has got some videos and some text that you can read just to understand it a bit better. I think it's easier to understand once you've watched some videos to show you, so you can gain a greater understanding of that. Okay, so we've got 3 experiments today, and you've got a lot of freedom in deciding how you carry these experiments out. And then you need to record your results, write a conclusion, and you maybe want to draw a bar graph as well to illustrate your results. So you're going to design your experiment, make a prediction, write down your results after you've thought about your method, and then write a conclusion. So I'm going to tell you about the 3 experiments now. So this one is an illustrative fair test investigation. So it's an investigation which you're looking at to show, what you need to show is a fair test, and you want to be able to see different results. And the question is, which trainer provides the best grip? So the setting for this experiment is you need to figure out which shoe would be the best shoe for a Formula 1 driver. And they need to have shoes which have good grip. So you need to test out some different shoes and test out their grips. I'm going to explain that a little bit more on the next slide. Okay, so here we have an example of a ramp. You could use a plank of wood for this. Think about the texture on that plank of wood. So it might be a smooth surface. It could be, if you don't have a bit of wood, it could be a large book. Obviously, you need to make sure your shoes are clean. You have permission from your grown-ups to use it, but this is just a plank to help me explain this experiment. So if I get my pen out, so imagine that you've got, let's say we choose 3 different types of shoe. So you might have a school shoe, you might have a trainer, and you might have a welly. And what we're mostly concentrating on here is the grip. Excuse me. So don't worry about the fact that the welly's got really long parts to put your legs into, because the design of the shoe is not important here. It's the grip and how much grip that provides to grip onto those pedals when they are changing gear. Well, they do change gear with their fingers, but when they are braking and when they're accelerating, they need good grip. So don't worry so much about the fact that wellies are quite tall. If you were to choose a welly or a walking boot, just be looking at the grip. So have a look at the bottom of those shoes to see if they have different grip. So then you could put them on your surface, and you want to see at which angle or at which height the shoe moves. So if I put my shoe, it's going to be a really basic drawing. So my shoe is going to just represent, have a little brick. So this shoe is here, and to test its grip, I want to see which angle or which height from the floor. Because if you don't have a protractor, or I imagine you can get a phone app, so that'd be a good use of your computing practice time as well, to measure the angle between the floor and your ramp, so this bit here. So which angle does your shoe start to move down the ramp? So if you start with it flat on the floor, and then if you move it up maybe 10 degrees, does the shoe start to slip towards the floor. If you move it up 20 degrees, does it start to slip? If you move it up 30 degrees, does it start to slip? An alternative to that is use a ruler to measure height. So you could measure it for example, every 5 centimeters. So lift up your ramp at one end by 5 centimeters, so it's tilted. Does it start to move? Yes or no? You could do that for each shoe. Then you could move it up and balance it so it's 10 centimeters off the ground. Does it start to move? Then you can move it up 5 more centimeters to 15. Does it start to move? You might find it's better to do it every 1 centimeter, because moving from 5 to 10 to 50 is actually quite a quick way of moving up those heights away from the floor. Or you might just have the plank of wood in your hand with a shoe on it flat, and then you tilt it slowly up at one end until the shoe starts to slip down the book or the plank of wood or the surface you've chosen, and then you stop there and you measure it. And which height does it start to fall? The one with the best grip is going to be the one that takes the longest, or that is at the highest angle before they start to slip, and then that could be your recommendation. So for example, if I've got my floor here, I'm going to use 3 different pen colours. So red, let's use blue. So blue is going to be my school shoe. So for example, if my school shoe started moving at this angle or at this height, if my trainer started moving when it got to this angle, and if my welly started moving when it got to this angle, I could say that my trainer had the best grip, and therefore I would recommend it to my F1 driver because it's got the best grip and more likely to mean the shoes don't slip. So there's things you need to think about here. So what equipment do you have for measuring it? If you don't have a protractor to measure the angle, or you don't have a phone app can do that, you could use a ruler. So do you have a ruler, or do you have a measuring tape? What are you going to put the shoe on so that it can slip and you can see? Is it going to be a bit of wood? Is it a smooth surface? Is it a book? You can decide that, so have a think about that. So you need to prepare your area for your experiment. How are you going to record your results? So you've got your 3 different shoes. You want to repeat this experiment at least 3 times to see which height or angle it starts moving from. Which shoes are you going to use to test it? You have to think about where you place the shoe on your bit of wood to see if it slips. Are you going to place it right at the top? Are you going to place it in the middle? Are you going to place it right at the bottom? I might suggest placing it at the top, because the back of the heel, if you're measuring the end plank of wood, that's going to be the back of the heel. It's going to be the same height as the ruler, isn't it? So that might be a good place. Or you might decide to measure it from the middle. It's up to you. So there's lots of things here, some really great independence in your experiments today. So it's all about you designing it. So you need to choose your trainers, choose the surface, choose how you're going to measure it, make a prediction, which shoe do you think is going to be best. Then you need to carry it out, and then you need to write your conclusion. Which one is best? Why do you think that? What is your recommendation for the Formula One driver? Okay, experiment 2. So this is an investigation, and this scenario is: the owners of a theme park want to create a ride where the carriage in which people are sitting is flung forward by a massive elastic band. They want to know what affects how well this carriage will travel. So I've just found an example here. This is called the slingshot ride. So this one's a bit different. It flings it up in the air. So let's go to the next page to show you an example. So here we have one elastic band, and we have just a sandwich tub, so a Tupperware. And the elastic band is put between 2 chair legs. And you need to figure out how you can make that tub go the furthest. So things you can think about changing, testing are the number of elastic bands. So if you put 2 elastic bands and flung it, you might need to put it between something that's not chair legs, something that's closer together to be able to do this. You definitely need to do it on the floor, because it's going to be a lot harder to measure it if you're flinging things up in the air. How far back it's pulled. So if you pull it back to 1 centimetre and 2, or you could do it every 3 centimetres, see how far it goes to get it the furthest. The surface on which it's travelling, so here you can see it's on carpet. You might have some wooden flooring in your house. You might have some tiles, maybe in your kitchen or your bathroom you could test it on. So once again, loads of independence here. So your results will be, so if you have different number of elastic bands, so your results have 1 elastic band, 2 elastic band, 3, 4, and then you've got your repeats, first repeat, second repeat, third repeat. So you need to decide. So if I'm doing different elastic bands, I'm going to measure how far it flings from the start. So the first one might be 2 centimeters. If I repeat it again, it might be 3, and then it might be 2 again. And then with 2 elastic bands, it might go a bit further. So 4 centimeters, 5 centimeters. And it might have an anomaly. It might go to 9 centimeters. I might work out my average at the end. Then 3, it might go up again to 7, 8, 7. 4, it might go back down again to 5, 4, 4. This is for you to test and to see which number of bands you could recommend to the theme park to use for their ride. So the reason I'm giving you these 3 different experiments today is I realise that not all of you will have all the equipment for doing these. I imagine for the first one, all of you will have a shoe or 3 different types of shoes that you can try out, and you would have a book or a bit of wood or some surface that you could put your shoe on to see which height it starts moving. Finding lots of elastic bands might be harder, so I can understand if you don't get this one done. So you just need to choose one experiment. So how you measure how far it travels. So you need to think about how you're going to measure things. Usually you measure things with a ruler. If you find that it travels particularly far, you might need measuring tape to measure that. Hope you're enjoying my Microsoft measuring. So think about how you're going to measure this, how you're going to make sure it's a fair test. Once again, loads of independence here, which is what you want to see in year 5 and year 6. You coming up with your own experiments. We're giving you the ideas. Can you carry these out? Then how are you going to record them? I showed you an example results table, or you could do a bar chart, and then you need to write a conclusion. So which one do you recommend? And you could draw a drawing. So you could draw your elastic band, you draw your tape, just to show how you carried out your experiment. So that's the second experiment. We've got one more to look at. And this one is, how can I make the most effective parachute? So here we've got some examples. This is a real parachute, obviously. This one is a paper. This is actually made out of a coffee filter. So if you have them, that might be one material you try. This website has suggestions on how you can make your parachute. So if you used this, for example, if you wanted to choose different materials, you wanted to choose paper, you want to compare 3 types. If you wanted to choose plastic, and then just because we saw the other one, we might have a coffee filter. What other material might you be able to use? You might have different types of paper. You might have newspaper, you might have printer paper, you might have card, for example. Compare them, and if you use the instructions on this website to make it with the string, then you can compare them, make sure they're all the same size. This experiment, what will you change? So I've just suggested you could change the material. How will you measure how long it takes to fall? So if you're always measuring it from the same height, so if you do it from head height, if you release it, how are you going to measure how long it takes that parachute to get to the floor? So how are you going to measure that? There's a clock, by the way. How will you make it fair? So if you've released it from head height, are you always going to release it from head height? How many repeats are you going to do? We've done 3 so far, but remember, the more you do, the more reliable it will be. Okay, so your task today is to choose one of those 3 experiments. Obviously, you can do more than one if you really want to do extra science, but my expectation is 1. You can do more if you want. That would be fantastic. You need to decide how you're going to carry out your experiment. You need to make a prediction. You need to record your results, and then you need to write a conclusion. Some pictures of you carrying out your experiments would also be fantastic. Okay, last bit. Amazing science. This is one of my favourite animals. This is a sifaka. So like the tenrec from last week, this is only found in Madagascar, and they're quite fun because this is how they travel. So they're mostly sort of arboreal. They're quite often in trees. When they're on the ground, they run along sideways like this, which looks very amusing. And this is one from the front. So that's a cool animal you might not have heard of. Okay, thank you very much for listening to your science lesson, and I'm very much looking forward to seeing how you get on with your experiments.